Here I'm going to look at a Leaving Cert past paper question on algebra. It's involving simultaneous equations. It comes from 2018 and it involves the elimination method for solving simultaneous equations. And what I mean by that is we can eliminate one of the variables at a time. So I'm going to rewrite these equations as 1, 2 and 3. I can see that in line 3 there's no y term. So what I might do is actually take 1 and 2 together and add them together so that I can eliminate y. Now to do that I need the coefficients of y to be equal but opposite when I add them together. So I'm going to multiply that one by minus 2 and I'm going to multiply this one by just by 3. So I'm going to rewrite 1 and that's going to be minus 4x because I'm multiplying it by minus 2 minus 6y plus 2z is equal to 8. So that's multiply line 1 or equation 1 every term there by minus 2. If I do what I said I was going to do to line 2 and multiply everything by 3, I'll have 9x plus 6y plus 6z is equal to 3 times 14, which is 42. At this point then, when I add them both together, I have 5x, my y terms cancel out because minus 6y plus 6y is 0y, plus 8z is equal to 50. Now I'm going to call that line 4, and if I do something similar to line 4 and line 3 by adding them together, I will be left with one unknown. So the aim, whenever you have 3 unknowns that you need to solve for, you need 3 equations. And slowly you just solve them using the elimination method, one at a time, to eliminate a variable. So next I'm going to take this line and I'm going to multiply this line by minus 5. And I'm just going to rewrite them, and I'm going to do it over here just for space. If I have line 3 and I rewrite it, it's just going to be multiplied by minus 5. I've got minus 5x plus 15z is equal to minus 5 times minus 13 is 65. Then I just rewrite 4 as 5x plus 8z is equal to 50. Right, I'm going to get some large numbers, but that doesn't really matter. Now what happens when I add those two lines together, I eliminate the x's, so I'm just left with the z term. So here I'm going to have 15z plus 8z, that's 23z is equal to 115. And that means if I divide both by 23, z is equal to 5. So I've worked out what z is. Alright, so I'm very close to finishing the problem now. I know what z is. If z is 5, I can substitute that into 4. So I'll just rewrite 4. And I have 5x plus 8 times 5 is 50. So 5x is equal to 10. X must be 2 there. And what I can simply do then is plug that into the original ones. If x is 2 and z is 5, I can work out what y is. So rewriting 1, I'll just do that here. I've got 2 times 2 plus 3 times y minus 5, which is z, is equal to minus 4. So I've got 3y equals 4 minus 5, which is minus 1. Bring that over, it becomes plus 1. 3y is equal to minus 3. Y has to be minus 1. So if y is minus 1, I've solved for y there. So there are my 3 values of x, y and z. Remember, it just involves a bit of patience. If you've got fractions in the question, what you might do is take a line and eliminate the fractions first of all by multiplying every term by the lowest common denominator. Remember, when you've got an equation, to keep that equation the same but in a different format, i.e. that the equation is still true, you need to multiply every term by the same number. Once you do that, you're fine. So the next question, solve the inequality. Okay, so we've got an inequality here. The thing about the inequality is generally with a fraction, if that was 2x minus 3y divided by x plus 2 is equal to 3, I could simply multiply everything by x plus 2. But with an inequality, we don't know whether that x plus 2 term is going to be positive or negative. And if it was negative and I multiplied the entire thing by x plus 2, if it was negative, I'd have to change the sign of the inequality or reverse it. Okay, if it was positive, I wouldn't. So I ensure when I'm multiplying or dividing by a number, I just ensure that I'm doing so by a positive number. And if x plus 2 is positive or negative, then I definitely know that x plus 2 squared is positive. So x plus 2 squared is definitely positive because any number squared is positive. So therefore, I'm going to multiply both sides by x plus 2 squared. So if I multiply the left hand side by x plus 2 squared, I end up with 2x minus 3 times x plus 2 squared divided by x plus 2. And that just cancels out one of the x plus 2. So I'm essentially just left with x plus 2 here, less than or equal to 3 times x plus 2 squared. Okay, so I expand my brackets here. When we're expanding brackets, first by first, first by second, second by first, second by second. Okay, just as a recap. So 2x by x is 2x squared. 2x by 2 is plus 4x minus 3x minus 6 greater than or equal to 3. That's out of, just do it one at a time, x squared plus 4x plus 4. Remember, a quick way to square something like that is it's going to be the first squared plus twice the first by the second plus the second term squared. Alright, so that's 2x squared plus x minus 6 greater than or equal to 3x squared plus 12x plus 12. Now I bring everything over to one side, and I'm going to do so just to keep the x squared term positive. It's just going to be easier. So essentially I'm just going to bring those terms over to the other side of the inequality, and that will give me 0 is greater than 3x squared minus 2x squared, which is x squared, 12x minus x, which is 11x, and 12 plus 6, which is 18. So I'm left with this quadratic. Now what I'm going to do is I'm going to factorize the quadratic. Straight away I'm looking for the factors of 18 that add up to 11, and I'm thinking 9 and 2. So x plus 9, x plus 2 less than or equal to 0. So critical values. X equals minus 9 or x equals minus 2. So just to show you what this question now means, this is a rough sketch of the graph. At x equal to minus 2 and x equals to minus 9, we're looking for all the values of x which return a negative value of y, because we're looking for every value where this curve is less than 0. So all the values of x which give us a negative value of y are all the values in between, so here, in between minus 2 and minus 9. That's the solution set to our inequality. Now, if I had done it and the inequality was the other way around, I would be looking for all the values of x outside of minus 2 and minus 9.